So now, for the most part, we have the circuit that you see there on the board, except for that's a 2200 ohm resistor. When you get resistors, it's a lot more common to get 2 and then followed by 2 values, in this case 2200, than 2 and 0, like 2000. So just be aware of that. But in any case, it's close enough. We just kind of got an estimate right there. And what we can think of for this circuit there is with 12 volts powering this red LED. Let's say we have a 1000 ohm resistor. That's going to be about 10 milliamps of current flowing. Red LED drops a couple volts, so 10 volts divided by 1000 ohms equals about 0.01 milliamp or 0.01 amps of current, which is 10 milliamps of current. And let's say we want about 50% more than that. Then what we can do is take a 2000 ohm resistor. So it's got twice the resistance. It's going to let half the current flow through, 5 milliamps of current. Pretty simple. Put them in parallel. You add up those two numbers. 10 milliamps plus 5 milliamps equals about 15 milliamps of current. Again, this is a 2200 ohm resistor on the lower end right there. But you can see we're close to 15 milliamps of current. And the power supply is not as accurate as a multimeter. But we even saw it like flip for a little bit. So it's probably kind of borderline, almost 15 milliamps of current. That is 2200 ohms of resistance, so it's probably letting through a little bit less than 5 milliamps of current. But in any case, if I pluck the 2200 ohm resistor, now we got 10 milliamps of current because it's a 1000 ohm resistor. Pretty straightforward, and not sure how well it's showing up on camera, but it does get, you know, a little bit brighter with that other resistance, but not a ton. But yeah, I can definitely see a difference in person at least. So hopefully you can on camera. Maybe if I dim the light a little bit. So yeah, it definitely makes a difference in person. 15 milliamps current is probably, you know, a good goal for red LEDs right there. Blue LEDs are really bright, so our green ones, you only need like a couple milliamps of current to get this bright. But in any case, we're going to add to this video. We got 2 parallel resistors right there, and you can do the same formula here for equal value resistors. The mental math on this one wasn't too hard either. Equal value resistors, no matter how many you put them in parallel, you just take their numbers and divide it by however many numbers there are. So if you had 3 1000 ohm resistors, you take 1000 ohms divided by 3, and you get about 330 ohms of resistance equivalent. So each one of them is going to pass about 10 milliamps of current. You get a total of about 30 milliamps of current, about 3 times as much current, because it's the equivalent of about a third of the resistance. Pretty straightforward. Now we got 2000 ohms of resistance right there. So it's more resistance than a 1000 ohm resistor right there. So we're not going to have half of the resistance. It's going to be higher than half. But of course, whenever you got parallel resistors, the resistance is always lower than the lowest value resistor. So hopefully that makes sense. If you got 1000 ohm resistor and a higher value resistor, you're going to have less than 1000 ohms of equivalent resistance. And again, the math isn't too hard on this one, but if you want to use the official formula for 2 parallel resistors, so if you got 3 or more, there's a different formula, but this is the simpler formula made for 2 resistors. So the equivalent resistance will be resistor 1, so we're going to use 1K for that, times resistor 2, 2K right there. And then you take that number and divide it by resistor 1 plus resistor 2. So I did the math right there. And again, I don't find this math terribly exciting, and I doubt most people watching this do either. So just going to go kind of quick there. But yeah, you got 2 million ohms divided by 3,000 ohms, which is 666.66 going on forever ohms of equivalent resistance right there. So you got 10 volts divided by this number right there, 2/3 of 1,000 ohms of resistance. In any case, you'll get 0.015 milliamps of current, approximate again. So again, the reason why we got 14, most likely due to I used a 2200 ohm resistor, so it's slightly less, but again, it's still close to 15 milliamps of current. That's all that really counts. Doesn't have to be spot on the LED is going to be basically about the same brightness either way. And the 2200 would be more accurate to use as a number, but the math would be more confusing. So I like to keep things as simple as possible. You don't have to do a lot of math most of the time in electronics. There's probably a few cases where you absolutely have to. But a lot of times you can either just do like mental math or just try out different value components. But as I said before, when you put resistors in parallel, you end up with less resistance than your lowest value resistor. So if you're already somewhat close to the value you want, like even 10 milliamps of current is close to what we want to put through the red LED, you add a relatively high value resistor in parallel right there. So that just lets a little bit more current flow through. And again, if I did like 10K and I'm like, oh no, that's still not enough current, then you know I could work my way down to like 2K or something if I got a little suspicious that 2K would add a little too much current. So any case, that's about it. Not a terribly exciting topic, but a pretty important one right there. And also, you don't have to memorize this. First off, I don't memorize this. If I ever want to know what it is, I look it up online, or I find my old diagrams like this where I wrote it out. And then also, you can just do a Google search of 2 parallel resistor calculator, and then it will just have slots for you. It'll say like resistor 1, resistor 2, you put in their values, and it will spit out what the equivalent value is when they are in parallel. Same goes with anything else that involves a formula. You just type out what that formula is, right there, 2 parallel resistors, into Google search and add the word calculator after it, and I can pretty much guarantee you you're going to get a calculator from some website. Who knows what it's from, but it'll probably be pretty straightforward to enter the numbers and get the results. So thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.